Rising along North Carolina's Outer Banks, both the Cape Hatteras Lighthouse and the Cape Lookout Lighthouse have guided mariners through one of the most dangerous stretches of coastline in the Atlantic for well over a century. Cape Hatteras, first lit in 1870, is the tallest brick lighthouse in the United States and a symbol of engineering resilience. Famously relocated inland in 1999 to protect it from shoreline erosion, Cape Lookout, completed in 1859 and recognized by its distinct black and white diamond pattern, has long stood as a critical navigation aid at the southern end of the Outer Banks. Today, both structures are showing their age. Decades of harsh coastal exposure, salt air, high winds, and constant moisture have taken a toll on the stone and metal components in the lantern rooms and observation platforms. The National Park Service is actively restoring these historic landmarks, focusing on preserving their structural integrity while maintaining historical accuracy. The National Park Service brought in EMS3D to provide 3D scanning to document the current condition of both the Cape Hatteras Lighthouse and the Cape Lookout Lighthouse, with a level of accuracy you simply can't get any other way. These structures have decades of wear, corrosion, and slight deformation in the ironwork around the lantern rooms and observation platforms, and every piece is a little different now than when it was originally built. By capturing high-resolution scan data, we're creating a digital record of exactly how everything exists today, down to the shape, fit, and position of each component. That data is then used to build precise CAD models, allowing new parts to be manufactured to match the originals, not just visually, but dimensionally and spatially, so they install in the exact same locations without guesswork. It's the difference between approximating a restoration and replicating it correctly the first time. To carry out the restoration work, full-height scaffolding had to be erected around both the Cape Hatteras Lighthouse and Cape Lookout Lighthouse. And while that made access possible, it created a real challenge for 3D scanning. The dense network of steel tubing and planks block clean lines of sight, which are critical for capturing complete, accurate scan data. Instead of a few straightforward setups, we had to perform dozens of scans from multiple positions to work around obstructions and fill in the gaps. On top of that, working at height introduced another layer of difficulty. Constant coastal wind, shifting conditions, and a limited stable footing all impacted scanner setup and data capture. It turned what would normally be a controlled process into a much more methodical, step-by-step operation to ensure nothing was missed. Getting to the site isn't simple either. Cape Lookout is only accessible by boat, which adds a layer of logistics you don't deal with on a typical job. On our first scheduled day to begin 3D scanning, a gale warning shut everything down. High winds and rough seas made it unsafe to travel out to the island, so the work had to be pushed. That's the reality of working in these coastal environments. You're on their schedule, not yours. Between limited access, weather windows, and tight timelines, even getting boots on the ground becomes part of the challenge before the scanning work can even begin. Once the 3D scanning was finished, the real grind began. We had to take dozens and dozens of individual scans, each captured from different positions, and align them all into one unified data set. That data registration process isn't automatic. It takes careful verification and adjustment to make sure everything lines up correctly and holds accuracy across the entire structure. Then came the cleanup, which was just as involved, because both the Cape Hatteras and Cape Lookout lighthouses were surrounded by scaffolding. The raw scan data was cluttered with steel framing, wood planks, and temporary platforms. All of that had to be manually stripped out without damaging or deleting the actual lighthouse geometry to produce a clean, usable data set. Only after that work could we generate a proper 3D scan file that's accurate, reliable, and ready for CAD modeling and downstream restoration work. So whether you are restoring centuries-old historic lighthouses or inspecting a modern aircraft, EMS has the equipment, knowledge, and willingness to travel to some of the most remote locations and work in the toughest conditions to get the job done. If you'd like to learn more, contact EMS at 877-845-2700 or email us at info@ems3d.com.